Very good evening, class. So today we are going to learn on analysis of vitamins in food. Last week we have focused more towards the introduction of vitamins. So this week we are going to learn the method to analyze the vitamins in food samples. So there are few methods that available in the market. Okay, if you check in the literature review, most of it are done by HPLC method, electroanalytical and UV visible method. So among these three methods, HPLC method found to be the most effective method for the analysis of vitamins, okay, in food samples. So as you all know, water-soluble vitamins can be divided into vitamin C and vitamin D, while fat-soluble vitamins are vitamin A, which is retinol, alpha-beta-carotene, vitamin D, vitamin E tocopherols, and vitamin K. So, and apart from that, in this lecture, we are going to focus on the food act tables, which is table 1, table 2, table 3, and 21st schedule, which is nutrient levels for infant formula, table 1 and table 2. So all these are the parts, components that we are going to, subtopics that we are going to focus in today's lecture. So class, let's start with the 12th Schedule Food Act 1983. So the listed vitamins, the following nutrient supplements are permitted in food. For example, ascorbic acid, biotin, calcium carbonate, and all those, vitamin A, vitamin B, vitamin D, okay, whatever is written here, okay, all these are the permitted nutrients according to the Food Act 1983. So there is another one table, which is table 2. So it's a combination, okay, food types of food, for example, bread, breakfast with carols, dry milk powder. So all these with the combination of vitamins with some other thing, the amount, how much it should be. So you can refer this table carefully for further information. And let's move on to the table 3. So nutrient supplement and the maximum daily permitted amount. For example, vitamin A, which is 5000 IU, thiamine 2.2 milligram, riboflavin 3.2 milligram. So it's clearly written here. So now we shall move to the 21st Schedule Food Act 1983. So this is mainly focusing on the nutrient levels for infant formulas. So class here, okay, in this guideline, okay, the minimum amount how much the vitamin should be and the maximum amount how much it should be. Okay, there are some vitamins they do mention the maximum, but there are some they don't even prescribe here. That means they didn't mention here, but the minimum value they do mention according to this Food Act. Okay, so let's move on to the vitamin analysis by HPLC method. Okay class, vitamin analysis by HPLC method can be done by HPLC with UV detection and HPLC with fluorescent detection. Okay, okay, for example, niacin, vitamin B3 analysis. So class, vitamin B3 analysis in Kerala foods, including infant Kerala products, flour, vitamin VB are water soluble and can be extracted from food at extreme pH using dilute acid or alkaline. So after extraction, the sample usually will be centrifuged and the supernatant will be filtered by using 0.45 filters as a cleanup step prior to the HPLC analysis. So for this type of analysis, amine type of HPLC column with UV detection will be employed. So the reagent, for example, like deionized water, methanol, formic acid as an additive will be used. So the vitamin standards are niacin or nicotinic acid, okay, HPLC with UV visible detector at 260 nanometer, and the HPLC analytical column which is amine analytical column will be used. So the range and the amount that they use, everything is here clearly. Okay, this is the condition for the analysis of vitamin B3. Okay, so the calibration standards at 10 mg per kg 20 of vitamin B3 with 20 ml of each. So the HPLC conditions will be 20 microliters standard conditions, fluoride with 1 ml per minute mobile phase, methanol with acidified water, isocratic elution, and the elution order is niacinamide followed by nicotinic acid. So the runtime is approximately 15 minutes total. The linearity range for niacin and niacinamide is about 0 to 50 mg per kg. So class, as for the determination of vitamin B1, thiamine, B2, riboflavin, and B6 pyridoxine in Kerel foods, infant Kerel products, flour. So B group's vitamins are water soluble and can be extracted from food using dilute acids. Basically, class, enzyme hydrolysis steps is included to convert the vitamins to the free forms. The enzyme has the additional benefit of ensuring the complete extraction of the vitamins and faster filtration of the sample extract by hydrolyzing any starch reagent. Well, after the extraction procedure, the sample basically will be centrifuged and the supernatant will be filtered via 0.45 micrometer filters to clarify the extract for the HPLC analysis. Post-column derivatization of thymine to the fluorescent trichrome compound is employed. So basically fluorescent detection is used for these three vitamins. So reagents, they use water, deionized water, phosphoric acid 10%, methanol, acetonitrile. Vitamin standard, they do use thymine, hydrochloride, riboflavin, pyridoxine, hydrochloride. HPLC instrument is a solvent programmer. So fluorescent detector. So they use fluorescent detector at the different condition. So the column is the C18 column, and this is the procedure for the working standard concentration and the amount that they use. So the analytical procedure, basically class, thymine, riboflavin and pyridoxine degrade in UV, which is including fluorescence light. So preparation and analysis should be carried out under the tungsten lighting, protected in an amber glassware or covered with the aluminium foil. So we should blend the Kerel samples in order to homogenize it. So once it's homogenized, we have to weigh accurately 2 gram of sample in duplicate as the quality control measurements in our method, and we have to add acids and autoclave it. Okay, remove from the autoclave, adjust the pH, then add some enzymes, incubate, then finally centrifuge and filter under the vacuum. Okay, again before the analysis process, we have to filter and mark up the volume with the water. So class, the HPLC procedure for this analysis will be, the condition is, it's a standard conditions. Okay, the mobile phase system for number 2 will be the, number 1 will be the methanol water, number 2 will be acetonitrile water, different concentration. So gradient elution for vitamin B6 and B2, isocratic elution using 95.5 volume to volume methanol water ratio. So detection limit, okay, they do report here. So vitamin B1, B2, B6, 10, 3.1. Okay, this is very low detection limit. So limit of quantification 30, 10, 0.23. So the linearity, given in a range here. So these are the chromatogram of the analysis of water soluble vitamins in vitamin tablets. Example of chromatogram class. So the standard pick is here, and this is the tablets form. So basically we are doing the vitamin, water soluble vitamin B. So class, vitamin B and vitamin C, the tablets do have the certain types of vitamin, okay, which tally with the standard. Okay, and these are the example of UV visible spectra of water-soluble vitamins: riboflavin, vitamin B1, B6, B12. There are three peaks, 1, it's basically 1, 2, 3. So folic acid peaks is somewhere around here. So class, now let's move on to the fat soluble vitamins. So as we know, fat soluble vitamins are A, D, E, K. So A can be divided into retinol and alpha beta carotene, and A can be found in fatty foods such as oil, margarines, butter. So class, basically vitamin A can be isolated from foods by using saponification process with the ethanolic pyrogalol and potassium hydroxide, and the extraction of the unsaponifiable material with diethyl ether. So after washing, the residue will be concentrated via evaporation, and the vitamins will be analyzed by using HPLC, okay, UV detection for the vitamin A analysis. So vitamin A, okay, how much it should dissolve, these working standards is everything clearly mentioned here, okay, under this method. So, and these are the condition for the HPLC. So for the retinol, the wavelength will be 325, for keratin 450, and C18 column. So the hydrolysis process. So class, basically 5 gram of the tested sample, okay, into the separate saponification flask. You must weigh, okay, into the this one, then prepare a check test by spiking. So basically we have to spike um, an oil substrate, okay, by spiking an oil substrate with, okay, in under in the sample we have to spike 1 ml of the each vitamin stock solution and analyze for the test sample, and we must use the oil sample without adding vitamins as a blank sample, okay. So it's one of the quality control method, and we have to test the food known for retinol and keratin concentration are ideal for a use as in-house QC samples, okay. Otherwise we have to get standard reference material if available, but very difficult to get. So we have to add the mixture with ethanolic pyrogalol, okay, and 20 ml of 50% potassium hydroxide. Purge flask with nitrogen, screw lid down and shake overnight. So as for the extraction procedure, quantitatively transfer either the solution to 500 ml separating funnel using 100 ml of water allowed to cool. So the procedure is basically they are adding the ethyl ether, okay, and shake for the 2 minutes to avoid the emulsion. Then the run off the bottom layer into 500 ml funnel and repeat the extraction, which is LLE. It's a very conventional LLE method. So discard the lower layer and add the upper layer to the first extract. So wash the extract with 10 ml of 10% of sodium hydroxide, sodium chloride, and wash the extract with tap water with neutral condition. Probably you can go for 3 to 5 washing. Then you have to add 20 mg of BMT to separate to the separating funnel and transfer the extract into the 100 ml of rotary evaporator flask and connect to the rotary evaporator and evaporate to just the dryness. And apart from that, you should remove the traces of water from the extract by adding a little of the methanol, and you have to re-evaporate it. So dissolve the residue in 20 ml of ethanol for keratins and dissolve in acetonitrile. So as for the keratins, we use acetonitriles, and for the retinol, ethanol. So if let's say the sample did contain both, if let's say we want to mean both retinol and keratin, so first round we can do with methanol, and second round we can re-dissolve in 10 ml of acetonitrile. So the HPLC condition is written here. So the injection volume, elution time, keratin summary conditions, elution, all these elution time, okay, which is about 15 minutes, okay. Quantification method, okay, what are the method they use? The formula to calculate the vitamin concentration, limit of detection 0.1, quantification 0.5. Okay, purity assay of vitamin usually Okay, this purity assay will only require when a new batch of standard is open, or when a stock standards are tested for degradations. So these are the chromatogram of the HPLC of fat soluble vitamins. So this is the vitamin E, okay, tocopherol, alpha beta tocopherol, and alpha tocopherol. Okay, so all these the vitamins here. So they do compare standard in the sample. Okay, for example, this is another one. HPLC of chromatogram of vitamin E. So this chromatogram shows these four peaks of the vitamins peaks separated well. Okay, and they do compare with different detection methods. So looks like the fluorescence have better sensitivity than the DAD method because the peak is very small here. Okay, the enrichment is very small. So the HPLC of vitamin E, so this is a margarine, and the standard when they compare, most of the margarines have the vitamin E, four different types of vitamin E. So okay. And I would like to introduce another one method for analysis of vitamin C, which is plerography method. So plerography method is very old method, is based on electroanalytical method. Okay, the this method was introduced by this man, okay, and he received a Nobel Prize in 1959 for his discovery, okay, and the development of the plerography method of analysis. So, and he is known as the father of electroanalytical method. Okay, Jaroslav. Okay, and polarography method directly contribute to the development of innovation ideas in electrochemical techniques, instrumentations, and application. So, well, class, we no need to go into very deep on the theory and the fundamental part of it. Okay, but you have to know, they are using paleography is basically is a branch of voltammetry method, and the standard of the electrolysis of solution, okay, of electro oxidizable and electro reducible substance between a dropping mercury electrode DME and some reference electrode, okay, which is saturated calomel electrode. So they are using some, dropping mercury electrode. Okay, so you can just go through the fundamental theory. Okay, I will just focus on the, okay, this is how the paleography cells will be, and the method with the mercury, the tube with the mercury and the reference electrode. Okay, this is how they will pack. It's a very old method. Okay, not much references also on this class. Okay, so I would like to just focus on the application part. So as we know, the polarography is basically used, okay, widely for the analysis of trace metals in the alloys, including ultra pure metals, minerals, environmental analysis, foodstuffs, beverages, and body liquids, toxicology, and clinical analysis. In the biological system, it is used to determine the vitamins, alkaloids, hormones, and so on. As for the medical field as well, paleography is used to analyze natural coloring substance of drugs and pharmaceutical preparations. Okay, so paleography analysis of organic compounds. So paleography technique is employed in organic chemistry for a qualitative and quantitative analysis and for the structure determination of organic compounds. Since the organic compounds are insoluble in pure aqueous medium, the solvent in which the organic compound and its electrode product is soluble is added to the supporting electrolyte. So example of solvent include various alcohols or ketones, dimethylformamide, and so on. So class, the widely employed supporting electrolytes, which are easily mixed with organic solvents, are various quaternary ammonium salts such as tetrabutyl ammonium iodide. So these are the list of the organic functional groups that are reducible at DME. So like ketone, aldehyde, alkene. So class, there are some of the organic functional group analysis that are non-polarography active group. For example, if let's say they are not non-polarography active group, they can be converted into the active polarography groups and can be determined the its polarography effects. Okay, for example, they use some reagent, okay, to convert non-polarography into the polarography so that it can give the polarographic effects. So these are the very common method that for us we will just learn on the ascorbic acid, okay, determination of ascorbic acid, which is vitamin C, by using the standard addition method. Okay, very simple method. Okay, we just take the electrode and put it into our juice to get the current value, so that we can plot the calibration curve and detect the amount. Very simple method. Okay, probably I would like to suggest to everyone to focus on more on the latest technique, okay, for the vitamin analysis. Okay, for example, HPLC method. Okay, so class, with that, I would like to end my lecture for today. Okay, and there is another one part which is involving calculation part. Okay, probably I will come with another one lecture notes, okay, for that, to explain the calculation. Okay, and we can have a discussion next week. Okay, with that, thank you so much class. Stay safe, stay home. Okay, and for those fasting, okay, happy fasting. Take care class.